I'm at the Geological Museum of China. It is near the Xixi metro station. I'm going to try out my little gadget here. I've got two of these headphones plugged in. Or a divided headphone, which was hard to find in the United States, but I found some here in China, actually at the Walmart in China. I bought these. I'll see how it works to record the video, since I can put one up to the microphone and the little thing that goes around your ear actually holds it against the microphone of the iPhone. It's pretty ingenious. I think I'm all too clever.
The Earth is composed of a combination of gaseous, solid and liquid layers that uniquely interact to make life on Earth possible. The Earth's outermost layer is known as the atmosphere. Within the Earth's atmosphere are found the hydrosphere, referring to the planet's mass of water, the lithosphere, referring to the Earth's soil and crust, and the biosphere, where all forms of life exist. Taking a look at the inner structure of the Earth, we can see that it is made up of three layers: the crust, the mantle, and the core. The crust, the thickness of between 5 and 100 kilometers, is very thin compared to the mantle and core below. The mantle is made up of a dense, hot layer of semi-solid rock. Under the mantle, the Earth's core is composed of two distinct parts: liquid outer core and a solid inner core.
This is an astronomical graph carved on a stone stele, 7th year of the Chen Yu period, South Song Dynasty. I think this is what I saw in Suzhou. Yeah, Suzhou Museum. This is at the Confucian Temple in Suzhou. They have this stele. You can watch my video of it. So, giant ocean currents called gyres, clockwise northern hemisphere, counterclockwise southern hemisphere, due to the Coriolis effect. That influences weather patterns. The wind tends to follow the ocean. Routes of Chinese explorers. 5 connected lakes.
Flying tour of China with a bird's eye view over her terrain, landscape and scenery. Let's start the adventure.
Oh boy. It goes off automatically as you walk around this thing. How do I start it? It's broken. Ooh. Pianchi. Three gorges. I don't want to narrate because I don't know when it's going to go off. Let's talk about 1111.
China's topography has been compared to a huge staircase descending in 4 giant steps from west to east. The highest terrain, averaging over 4,000 meters, is to be found in the Qinzhang Plateau to the southwest of China. The second step, 1,000 to 2,000 meters in elevation, is formed by the vast plateau basins to the east and to the north of the Qinzhang Plateau. The third step, formed by the hills and plains of eastern China, which are lower than 500 meters, finally dissolves to the saturated mountains. China's climate and economy has benefited from its unique topography. Moist air flowing in from the sea to the interior provides life-giving rain for the shipping routes of China's great rivers flowing east, strengthening economic connections between the coastal and inland provinces. Topographic maps for the
contour line and topo maps. Solar and lunar eclipses. It's a total eclipse of the heart. The Earth's surface. 20% dry land, 71% water, 29% dry land. Most water is found in oceans. Protects the Earth's surface from large temperature changes. When seen from space, it appears as a blue ball with the continents resembling small islands. Earth's outer layers is what they're talking about initially. Whoops. It slides off this thing, it doesn't want to stay on. I'll have to engineer it a little better so it'll stay on better. Son of a bitch. I think what it is, I'm pulling it maybe. I'm pulling the wire. It comes off. The wire gets snagged. 1021. It's boring. 1011. Space, the final frontier. If I want to go from San Diego down to Hawaii, I just follow those northeast trade winds, baby. Then I gotta circle back around northerly. If I want to get home, I could land in San Francisco. Yeah. Follow those trade routes. Tectonic plates. Intergalactic, planetary, intergalactic, another dimension. Strata and folds. I was hoping more that they would talk about China geologically than trying to educate me on the rock cycle and that kind of nonsense. It's so boring, and I've been through this. I take an 8th grade Earth Science. Then again, at the Biosphere 2 Center, I take this crash course. Volcano distributions along the Ring of Fire. Along the Ring of Fire. See that? Rift Valleys and Rings of Fire. Along the Pacific edges of the Pacific Plate. Pahoho, basalt columns, hexagonal basalt columns. Devil's Postpile, they call these. Pahoho and Aa. That's what we call them. I don't wonder if they use the Hawaiian names here. Globe volcanic rock bomb. Shooting them up. Causes the earthquakes and distribution. All along the plates. The Circum-Pacific Belt is the Ring of Fire. Intergalactic Planetary. The Himalayan complex is the Trans-Eurasian Belt. Also along ocean ridges is where the crusts come back together instead of splitting apart. No, they split apart instead of coming together at the ocean ridges. 1062. Intergalactic.
Location inside the Earth, where the seismic wave earthquake occurs, is called the Earth's hypocenter. The area directly above this point on the Earth's surface is known as its epicenter. Seismic waves produced by an earthquake radiate outward from the focus at its epicenter. Even though it is impossible to prevent natural earthquakes, strategic and contingency plans can be drawn up to help limit damage to life and property. People living in earthquake zones should know how to deal with an earthquake and its aftermath. Household emergency procedures detailing how
Under the table,
difficulty
in the doorway,
rehearsed several times a year.
in the corner.
Such training often combats instinctive reactions
That's where you hide out.
earthquake victims in even more perilous situations. For instance, rather than running from a room with the possible consequence of being hit by falling objects, earthquake victims are advised to stay put, find safe shelter, and to adopt the correct body posture to minimize the shock.
This is something I didn't get to see when I went to Shishan in observatory. I walked right by the area where they had it. It's the original seismograph. Di Dong Yi seismoscope. Zhang Heng invented the seismoscope, also called Di Dong Yi earth motion instrument, in AD 132 East Han Dynasty for measuring earthquakes. Zhang Heng's device was the first instrument of its kind in human history. The device's general shape is an urn. 8 dragon heads made of bronze, each keeps a ball in its mouth around the top outside of the urn, and 8 frogs made of bronze with their mouth opened, each squat perpendicularly under a dragon head. When an earthquake occurs, a ball fell out of the dragon's mouth into the frog's mouth. Accordingly, one can roughly determine the direction of the quake. Here shows the dwindled duplicate of the Zhang Heng seismoscope in accordance with the biography of Zhang Heng, recording the history of the Han. I don't know if it's a model they have too at Shishan. I think it's bigger. I didn't get to see it. I walked right by it. I didn't know it was there. And so when you're going up that gate that everybody goes up in May to Shishan Cathedral in Shanghai, there's like a way they walk up. The via something or other. Distribution of China Crustal Movement. Intergalactic Planetary. My next destinations that I would like to visit, now that I've been to Shanghai, Beijing, Hangzhou, and Suzhou, would be Nanjing, Wuhan, Chengdu, where's Chengdu, and Xi'an. I guess I could do this. Nanjing, Wuhan, Xi'an would be a good trip next summer, maybe. Hells yeah! I'd also like to see Fuzhou, Guangzhou, Changsha. I've heard some stuff about. Might be nice. I could do this. Wuhan, Changsha, Guangzhou. Heck yeah! I'd also like to get out to Lhasa. Where's Xinjiang? That's where I'll have all the trouble now. Fixed stations, strong motion network, planned projects, distribution earthquake precursor network, seismic observation network, digital seismographic emergency response directory. Beautiful. This is what I want to learn about. Here's the subcontinent of India, splits off from Sri Lanka and blasts its way into Asia. That's why they call it a subcontinent. 71 million years ago, 55 million years ago, 38 million years ago, and 10 million years ago. Bada boom!
The Himalayan mountains and the uplifted Qinghai-Tibet Plateau have a great impact on climate and environment. The Himalayas divert precipitation to the south and east of the Qinghai-Tibet Plateau, therefore preventing moisture from reaching the Gobi and Mongolian deserts. They may also be responsible for intensified
Ah, shit. Monsoons. Intensive monsoon. See, I messed it up by lifting it too far. I forget it's on there. And I reach for the stars. Reach for the stars and you will fly. You're hungry for heaven. So Tibet in plateau is why you have so much moisture in Southeast Asia. The moist air from the Indian Ocean gets heated up like it does over the Gulf of Mexico and the United States, and doesn't have anywhere to go when it hits the Himalayas, so it gets forced southeastward and dumps its rain as monsoons over Southeast Asia. And then Qinghai Lake is the inland lake where all the water drains into. It's real salty and high concentration of minerals. It's the largest lake in China, so they say. Freshwater lake, I guess, or not freshwater, largest not freshwater lake maybe. And the Himalayas are getting bigger by 5 millimeters every year. Model of Sinan Han Dynasty. Looks like some sort of alien movie contraption. Chinese ancient 4 great scientific inventions. Original model compass. First Sinan was made during the Warring States. Sinan consists of Shu-O spoon and an earth plate. The Shu-O is made of metallic magnetic material in ancient time by natural magnetites or lodestone, and the earth plate is made of copper or other non-ferrous material in ancient time by bronze. As the Shu-O is set on the earth plate, it points to the south when it comes to rest. So it'll be moving around. You spin it. Is it the idea you have to spin it? And then when it slows down, it'll point to the south because it's drawn to it. Glaciers. Glaciers.
The speed at which glacial ice flows is influenced by several factors, including the slope and roughness of the ground, the thickness of the glacier, temperature, the incidence of water between the glacier and the earth, and the amount of snowfall. Viewed from above, little of the glacier appears to flow at the greatest speed. Surface movement is slower at the sides, the bottom of the glacier, due to surface friction created by valley walls.
(1081, 1082).
Around 1/10 of the Earth's surface is covered by glaciers, with approximately 85% of that total to be found at the South Pole alone, and a further 12% to be found in Greenland.
Cave formations, underground water, and sinkholes. Carbonic acid. The water combines with CO2 to become carbonic acid, which forms a weak acid, the same as soda. And when it gets down into limestone, it wears it away, just like soda wears away your teeth. Although that's more from the sugar and the bacteria, but somewhat from the seltzer. That's why I shouldn't drink seltzer water all the time. Effects of water on land. Effect water has on landscape can be seen everywhere on Earth. Blah blah blah. Southeast China, heavy rain. Eroding the hills, lower and smaller hills. Southwest China, deeply cut rivers have formed many spectacular valleys, such as the 1,000-meter wide V-shaped valleys of the lower range of the Lancang-Jiang River, U-shaped valleys of the Three Gorges along the Yangtze River, between Badong and Jigui, and Hutao Tiger Jump Gorge on the upper range of the Yangtze, and the recently surveyed Yulu Jiangbu Grand Gorge. In China, the Huanghe Yellow River removes over 1 billion tons of soil and sand per year from the Loess Plateau. As the river slows, about one-half of this material is deposited on the riverbed in the floodplain, creating a vast alluvial delta beneath Mengjin. Many of the soil and sand is discharged into the sea. This action not only extends the floodplain in the sea, but also raises the riverbed above the floodplain so that the river frequently floods and it changes its course. 60 square meters annual rate of growth of the delta. Channels in these streams are characteristically U-shaped.
Many distinctive wind-eroded landforms, including boulders, mushrooms, castles, and sand dunes, have been molded by sandstorms. Their violent winds carry clouds of sand and dust through the air. Over 1/4 of China's territory is taken over by deserts, totaling around 2.6 million square kilometers. Half of this area is occupied by the Gobi, China's largest and most well-known desert. 4 main areas of sandstorm activity have been recognized within China's borders. They are located in the area surrounding the Taklamakan Desert, notably the Hershey Corridor in Gansu Province, and the Alishan Prefecture in Inner Mongolia. In the area to the northern side of Yinshan Mountain in Inner Mongolia, in the Hunsha-Daka Desert area, as well as along remnants of the Great Wall that still survive in Shaanxi Province and in the Inner Mongolia and Ningxia Autonomous Regions.
Let's see what's in here. I'm playing some kind of video. Lady in white gloves, what's she doing?
长期从事底层古生物学、矿物岩石学、宝石学和博物馆学研究，并取得累累硕果。特别是在早期脊椎动物学、昆虫学以及辽西热河生物群等研究领域所取得的成果，受到国内外科学界的广泛关注。以系统精美的宝石陈列、独到的宝石研究成果。
Got some signs here. Himalayas divide, prevalent west winds, and two currents in the troposphere above the Qinghai Plateau. The North Stream flows parallel with the Gobi Desert on the lowest plateau. This area is in a rain shadow caused by the Himalayas and is therefore very dry, with high winds caused by large changes in day and night temperatures. A cycle is developed where the dust and sand are picked up off the ground in the Gobi Desert, circulated thousands of meters high in the sky, and then deposited on the lowest plateau. Fine sand patterns have accumulated on the lowest plateau since the beginning of the Quaternary, 2.5 million years ago. It's an important resource for humans because it creates very fertile soils. The lowest plateau is the most widely distributed region of loess on Earth. Loess is fine silt, essentially. Sandstorms, wind erosion. Who's Mushroom Castle, blah blah. Mud flow, rock fall, rock landslide. The effects of water on land. A vast alluvial delta beneath Mengjin. I was reading before when it went off. Rivers. Channels and streams characteristically U-shaped and wind back and forth over the floodplain. So that's what they mean by U-shaped. Usually in geology when they talk about U-shaped, it's glacier carved valleys have U-shapes. And this would be, we'd call it an oxbow bend in the river, or meandering. Sandstorms. 4 main areas of sandstorm activity: Heshi Corridor, Gansu Province, Alishan Prefecture, Inner Mongolia, surrounding areas of the Takla Makan Desert, northern side of Yinshan Mountain, Inner Mongolia, and the Hun Shadaki Desert area, along the Great Wall, remains in Inner Mongolia, Shanxi, Ningxia. The majority of sand that pollutes Beijing originates in Mongolia, either passes through the western Hun Shadaki Desert or Inner Mongolia, Huadi and Jiangjiakou to Beijing, or originates from China-Mongolia boundary area between Hami City of Xinjiang and Alishan Prefecture of Inner Mongolia, and passes through Heshi, west to the Yellow River corridor, Yilanshan Mountain, and Mawusu and Ulanbuhi deserts, Huhohet and Jiangjiakou, to finally end in Beijing. Erosion and sediment. So stuff gets worn down, essentially. Smaller and smaller and smoother shapes usually, but it depends on whether it's wind or water or what. That's most of everything down here. I guess I'll go upstairs. There's 4 floors this size in the building. And there were some big rocks outside they had on view.